Turn our attention to the deployment pipeline. This lecture is basically a high-level overview, and we'll go into details in subsequent lectures. So the deployment pipeline models the workflow of code. So developer creates and tests codes on local machines, and then they check their code into a version control system that typically triggers a continuous integration, a build process by the continuous integration server that builds the system and runs a series of integration tests. After passing, these are typically functional tests. Does it do what it's supposed to do? After passing the tests, the system is promoted to a staging environment where there are more tests. These are non-functional types of tests: performance, security, and potential user acceptance tests. After passing these tests, the system goes into production, and then there are even more tests. So it's really a provisional production stage, and then finally it's promoted to normal production. But even in that case, there may be tests that go on, and again, we'll talk about all of this. So the goals during this process are that team members work on different versions of the system concurrently. So even within a particular team, one member may be working on a bug from a release version, another member may be working on the next version of that particular service, and so on. The code developed by one team member does not overwrite the code developed by others. You don't want various types of interference. That the code produced by one team can be integrated with code produced by other teams. All this certainly should make sense. You'd like the code to be the same as it moves through the deployment pipeline. So you don't want to have to change the code to reflect the fact that you're in staging, for example. The different stages serve different testing purposes. You want to keep the different stages isolated from each other. In particular, you do not want to affect the production environment while you're in test. And finally, and not so obviously, is that you want to have a rollback process. Okay, a deployment can be easily rolled back if there is a problem. Now, what are the qualities that you would look for in terms of a deployment pipeline, other than doing the tasks that they're supposed to do? And we'll talk about three of them. So there's traceability. When code gets into production, you must know where it comes from. So all components can be identified, all tests that were run can be identified, all scripts that were used during the pipeline process can be identified, the versions of the tools that were used in the pipeline as it gets processed should all be identified, and so on. And this allows problems to be more easily traced. So if you know if a particular instance in execution production has a problem, then you know where to look. Was this done before that bug was fixed or after that bug was fixed, and so on. Every stage has an associated test harness. I'll talk about tests in a minute. Tests should be automated. Okay, so testing is a time-consuming process, and as we said in the introduction, we want to increase the velocity of the deployment, and so this is done through automated tests, one mechanism. So you have sunny day tests, does everything work the way it's supposed to? You have negative tests, what happens if I do something wrong? You have regression tests, what happens, has happened to the bugs that I found previously. And then there's analysis. You can do static analysis, code analysis, to look at the code and detect certain types of problems. We'll get into this in more detail. So first, let's talk about a test harness. So a test harness is a mechanism whereby you can run automated tests. The tests will talk to, for example, a load balancer, which has some number of virtual machines that it's managing, and some database that the virtual machines are accessing. There's some configuration specification, and there's some external things that the virtual machines interact with. And so then the test harness will look at the results and decide if the results are appropriate for the particular tests that it's doing. And there are a number of tools that do this. The kind of tools that you use in the deployment pipeline are the version control. One of them is a version control system. So this manages different versions for production and development. Git is the most recent entry in this, and that's a distributed version control system that I would say pretty much everybody's using at this point. I don't know if that's totally true. There's a configuration management tool, and that controls the configuration. So samples of this are Chef and Puppet or Ansible. In our assignment, in your assignments, you'll be using Chef this year. Last year we used Ansible. There's a continuous integration tool. It builds the image and runs functional tests. And Jenkins is an example of this. And then there's a deployment tool. So how do you, once Jenkins has finished building, how do you get it into deployment? And that there are specialized tools. There's one called Spinnaker. There are also the configuration management tools, because in some sense this is a configuration management problem to put things into deployment, and so Chef or Ansible are examples of that. So all these tools have to execute on a platform, and the platform you're going to be using for all but one of the assignments is VirtualBox. One assignment will be using Amazon Web Services. And Vagrant is a tool that you use that provisions a platform. So how do I build my virtual machine? What goes into it? Those kinds of things are managed by Vagrant. The other tools too. I mean, these tools all overlap, so it's hard to draw sharp lines. But Vagrant is explicitly a provisioning tool. So you go through a variety of environments. So, and again, we'll talk about environments in more detail. But there's an environment where you're developing. So as a developer, there's an environment where the integration happens. There's an environment where the staging happens. There's the environment where production happens. So again, this mirrors the workflow. Some organizations have many more environments than that. So this is kind of an abstraction of the different environments that might exist. So just to summarize, a deployment pipeline, it's a series of stages where each stage has a specific purpose, either for testing or building. Each stage has an isolated environment. Each stage has some set of tools that it uses, and the pipeline has a set of desirable properties that you can use to measure its performance.